Hello, I'm David Cadron. This video describes physical behaviors that affect rate and recovery of non-thermal heavy oil production from unconsolidated sand reservoirs. Gold production is currently dominated by three types of well configuration, 3 sand strategies, and 2 recovery techniques. Cavity completion more aptly describes the practice of near wellbore sand removal that stimulates heavy oil inflow, rather than chops, which conveys the notion of continuous high rates of sand production.
Unconsolidated sand reservoirs are a gradation of particle sizes. Slotted liners form bridge structures from the larger particles to filter out the smaller particles. All filter systems develop filter cake on the inlet side. The greater the solid content, the faster the filter cake builds. Filter cake must be removed to restore flow.
Near wellbore sand removal extracts more oil per individual well than sand exclusion. Near wellbore sand removal produces more oil per meter of horizontal penetration than sand exclusion. Perforating a slotted liner or sand screen to remove near wellbore sand after oil rate has become uneconomic can boost rate by a factor of 3 to 29 times. Perforated vertical wells drain 2 to 3 acres after sand removal. Infill drilling has shown original reservoir pressure exists 80 to 150 meters from a depleted perforated vertical well. Production rate from a horizontal well is incremental accumulation of drip rate inflow from each meter of reservoir accessed by the wellbore. A continuous flow rate of several thousand cubic meters per day is required to transport sand in commonly used liner diameters. The volume of sand extracted from a perforated vertical well is relatively small. Sizing slots in a horizontal well to allow sand inflow the length of a liner would generate an order of magnitude more sand for disposal. Depleted cavity completions accept large volumes of solids using gravity feed. Slurry injection can dispose of 50,000 cubic meters of sand in a 300-meter diameter around a well. Low recovery from injection schemes in unconsolidated sand reservoirs is due to its physical composition. Up to 30% compaction can occur in situ because the sand grains are barely in contact with each other. Lack of cementation between sand grains results in parting pressure of about 1 MPa. In comparison to a lab sample, there is essentially no lateral containment of sand grains in situ. Injection relocates sand particles, rapidly creating channels capable of passing 7 mm spheres 400 meters through the reservoir between injectors and producers. To summarize, near wellbore sand removal requires fewer wells to drain a pool than sand exclusion completions. Sand volume removed is small relative to the sand in the drained area. Depleted wells can dispose of more sand than was extracted without harming reserves or the environment. Physical composition of unconsolidated sand reservoirs allows for large diameter channels, which limits flood scheme recovery. Pool recovery could be increased to 80% if well spacing was based on actual drain diameter of cavity-completed wells. Directional and horizontal drilling would avoid a Kern River, Bakersfield type landscape. Infill drilling cavity completion wells is a low-risk method of increasing pool recovery. Open-hole multilateral wells are the least effective well type for recovery from unconsolidated sand reservoirs.